Are there any questions that you have relating to the correlation coefficient?
Yeah, like I mean, how can we find that out? Like I mean, like we just like tested for example with 250 the last time, and then we just said okay, let's I don't know start with 5. Like what if we would have said we start with 10? I think we wouldn't have gotten like this outlier, right?
Yes. Now, this is where that's a good question. This is where really a lot of the research and intuition comes in, because what I've done here really is also I just looked at the charts and I said, oh, look at this and look at the others. Okay. And from there I could go, oh, okay, this is interesting. Now, one thing you could do is let's just do this for the sake of doing it. So if we just copy this, right, and then like I create another code box, or let's just do this here, and we just put a few more of these in. Let's say we run the 5 again, which we have lost basically previously, and then let's just say we do a 50, and let's just say we do, I don't know, an 80 or 90. Yeah.
Mm-hmm.
And then we call this, I just want to keep it simple. I don't need a T. I just go with a P. So we go P3, um, P4, and P5. Yeah. So I just run these three. It'll take a little bit. But what I can already do is I can actually add them in here. So I go P3, yeah, P4, and P5. So what I'm doing now basically is I'm extending, or I build a covariance matrix with 5 components instead of just 3 components. Okay. So let's see. So when this is finished, so we've got f.shape is now 5, right? And now we've got a covariance matrix with 5 components. Okay. So we can see here, this is our one with the 5, that we had before, 0.03. But what you can see here is already quite interesting, because you see another one. There is one here with 0.06. And then there's another one here with 0.09. They're all quite interesting. Whereas the ones, with 0.87 is not useful, 0.5 is not useful, 0.6 is not useful. So when you do this parameter sweep, you could basically get them all, and then look at the covariance matrix and see what happens. I think there is even something you can use colors, something like this PLT. I think it's like this PLT.imshow. I haven't done this yet. F. And okay, no, this doesn't work, unfortunately. Oh, no, hold on. We need to do this coefficient of F. So you can actually plot like, see this? This is this is effectively a heat map, you would call it. And the high or the lowest values are or the highest values are the light ones, and the lowest values are the black ones. And so if you had like, say 100 tests or so, you could see this large heat map, and you can see perhaps areas of where you get the darker spots where there's lower correlation, and say, well, we pick a few strategies that have low correlation to each other, and then use those. And yeah, so if you want to know, I think with the heat map you could actually also put a color bar on that then gives you the oh yeah, see this? You've got a color bar now. You can see, oh, my lowest correlations are the really dark ones, and then the highest correlations are the brighter ones. And if you want to get rid of the grid lines, you could also do a plt.grid. And there you go. You've got a nice heat map of our covariance matrix. and you always see the diagonals always like the same color. So people do this a lot. And then that gives you a good idea of, say, if you had like 100 strategies or so, you got obviously a huge heat map, but it gives you a good idea where there's some interesting things happening, and you can just go and pick them, for example.
Mhm.
So that's just one of our little tricks.